Okay, hello. We are ready to start. Today we continue our lectures and seminars. I have sent yesterday a list of several tasks, so we are already almost here. Almost because we have several students, and not all of them now at this point. Some of them are not, or maybe they are, but I just don't know about this. And some problem here because it's a very small point, but upgrade code from 1 to 11. Indeed, there is many points to be upgraded, but maybe upgrades will be not large. So I hope that we will complete this task in this model, maybe in the beginning of the next. And then we will have some kind of project there. I, I think that our project, your project, might be applying this software for some problems to create some kind of investigations there. So you can find their graphics and maybe diagrams there and so on. Some kind of research paper. Well, maybe without many details, but it will look like a research. I hope at least. Okay, so what we have here by now. Okay, if you have any question, you already you can ask them. So now we have we are given matrices. Two matrices. Now we can find all Nash equilibrium there. And if we are given graph there, we can get, and we can get these matrices here and then get Nash equilibrium. If we have some data, we can get graph from there, get matrices, and get Nash equilibrium here. This one is task number 1. This one is task number 2. This one is task number 3. So the fourth and fifth and even sixth one is some kind of upgrades here. 4, 5, 6. Some kind of options here. If someone he doesn't want to use Nash equilibrium, he might want to use rationalization method or Maximin equilibrium. Maximin, sorry, not min-max, but Maximin. Yes, and maybe a Pareto set. I have described Pareto set, so maybe you already know it. Maybe you have already developed a code for this. So if we have kind of diagrams for this, so if we want to talk about Nash, so we want to find, and we have two matrices, want to find all such elements here. That is maximum here for the first player and maximum here for the second. Rationalization means if we have two matrices, then we eliminate some of columns here, some rows, and do it several times. based on the algorithm. There's some kind of rationalization. Okay, this one, max min, means that if we have two matrices, then we try to find here the minimum value here, here, and also here. For every column, we're trying to find the minimum value, because we assume that our opponent will play directly against us. It's easy to imagine for a two-player game, but if you have three players, okay, Manuel, it's not very easy to think. So, for example, we have two players, and sorry, it's Emmanuel. He wants to. I don't know. So no, not here. Wait a minute. I don't know what's wrong. Oh, maybe. Oh, he might be. Oh, okay. Thank you, Leah. Thank you. Okay. I was sure that I switched off to Telegram, but indeed, no. Okay. So yeah, and it's a problem. For example, if we have two players, and the third player, he has to be an opponent to the first player and to the second player, and each player he assume that this third opponent he will play against him, but sometimes it's impossible. So if a player 3 he will play against player 1, he cannot play against player 2. For example, if we imagine that there are two spots here, like two towns, like a Disney town here. This one is for player 1, this one for player 2, and player 3. Player 1 he thinks that player 3 will attack him because of Maximin strategy. Player 2 think that player 3 will attack him, but it's impossible for player 3 attack both of them, so he has to choose. So sometimes this concept of max min is not very easy to understand, but it's some kind of very safe strategy here. Okay, and when we have here minimum, then we are trying to find here max here and max here, max and here, max among them. This one is maximin. So this one task number 1. This one is number 4, 5, and task number 6 about Pareto set. So we have two matrices, and we take an element here, and we check, as in the first variant for Nash, all variants, but we have one more criteria. So it not only, well, we should, it might be that this place is, well, this element is better for the player 1 than this one, and it won't be Nash equilibrium. But for Pareto set, Pareto optimality, it might be that this point is worth for the second player, so they don't want to make situation worse for his opponent. So it's some kind of Pareto set. Sometimes people, they talk about Pareto when they have two functions to optimize. For example, we might want to optimize time and resources, money, for example. And we understand that if we have no money, we have to spend a lot of time. If we have no time, we can spend a lot of money. There is a there is a curve here, and we might have a restriction here, and it might be that we cannot get more. For example, we want to create one. So this curve is some kind of requirement to solve problem P, for example, here. And we cannot get more money without loss of time. And we cannot get more time without loss of money. Yeah, and this curve is some kind of Pareto set, because we can imagine that there is one agent who wants to optimize time and another one who wants to optimize money. In this case, it will be some kind of game, and we will have Pareto set. That's number 6 here. And then we will go to information set. Information structure. This one is slightly new. So I would like to introduce it now, and then we'll go back to our first tasks to discuss our progress. So information structure that is described here in mentioned here in the task 7 means that, let's imagine that we have a graph, and we might have a graph with several parameters there, like A, B, well, maybe A1, N parameters. For example, A1 is availability of age from, I don't know, maybe from city 1 and city 4, and AN is availability of age between 7 and 10, and so on. In this case, we might want to think about alternatives, all variants of this graph, and we might want to construct an informational structure for this. The generator, some kind of generator, this one, he creates a set. Well, indeed, it's a graph, but maybe we don't need networks here, maybe just lists. So the idea is to enumerate all graphs here, create graphs. Maybe we need networks, yeah, using these parameters. So it might be that we have some graph, initial graph, then we have some kind of function, well, let it be a function M from initial graph G, and vector, a list of parameters here, like this one. And then he returns all variants of graphs. So we can have, we might want to have here enumeration. Well, so we have graph 1, graph 2, and so on, depending of our lists here. It's all possible variants of this transportation network. So the first variant, the second variant, and so on. It's the set. Oh, the set of, and we know how many words we need, because if we have availability just from 1 and 0 set, so it's binary. We have n, okay, k here. In this case, we have 2k graphs, and then we might want to have here agents, or we might want to first of all connect those graphs which are not which cannot be distinguished by an agent here. Let's say first one, second, and we will place here several instances of agents. For example, these two graphs cannot be distinguished by player 1, and we might want to use this thing. At the same time, these two cannot be distinguished by player 1, but at the same time, these two players, these two instances, they observe different features of this one. So we might think that, for example, we have a graph here. This one. We have two parameters here. So we have this one, we have this one. We might have this one, and this one here. So we have three variants of graphs. And if we are given a list of ages or list of parameters that are known for agents, for example, we might think that for first player or agent, first player, the second player, the first player, he knows A1, and the second player knows A2 here. So we can represent it as just list 0 or 1 here. A player who knows everything has this list here. Who doesn't know A1 and A2, he has empty list here. And we okay. Sorry, what should I have here? Okay, I see. Yes, and these two cannot be distinguished by player 2 because he can have information about A2, this age, it's the same here, but he has no information about A1. And here the same. This one's the first one. There is an algorithm. It's very simple that I use to construct such structures for this situation. Okay. Yes, and before this, we can place here a node for first instance of player one, and node for the second instance of player two. That would be like no, the second instance, and the same here. Well, when we create such structure, so the idea is that we create all possible variants of graphs, some kind of list here, and we have a partition. So we divide this list into several lists, smaller lists like this one, this one. They have the following property that agent, this one for agent 1, the similar one for agent 2, but not the same, maybe, that for in each part, all parameters of that are known for agent 1 are the same. For example, if agent 1 knows only parameter a1, in this case, you will get such splitting. So here is all graphs where e1 equals 0, and here all graphs where elements equals 1. If we had several edges, then we will have more parts here. So we'll have a1 equals 0, and a2 equals 0, and so on. So this kind of partition. Such partition might be called, well, it's like it for knowledge structure or information structure. And if we assign here, or we might imagine that we have a special instance of this player 1 here, player 1 here, here, like I did on this picture. In this case, we will have this informational structure even in this form, and it's some kind of bipartite graph, as I have described before here. So we have instances of agents, we have graphs, but I prefer, well, it's classical thing. It's not something that I have invented. No, it was known for a long time ago. And so we have partition here for agent 1 and for agent 2. Okay, we can do this in Haskell and Python. There are such variants of this. And then, so it's the solution for, it's the idea of solution for this one, for 7. All this here, here, all this is their task 7. But maybe it's more simpler to create software to or write a code than to just draw these pictures. But these pictures are very useful for interpretation here. For example, we have great pictures here, we can discuss them, and we can even find solution here without coding and so on. Okay. And then task 8, we will create game here for every variant of our graph. So we have, for example, here we have graph. And for this graph, we can create metrics like utility functions, like we did in task 1. But for specific graph here, for this one, of course, for enumeration purpose, we might not use just graph, but only a list of parameters here. And then if we have such a generator here, we can get from our list this graph directly. So this was the idea of this graph. Indeed, it looks like you eliminate or create edges in this initial graph. So if you have list, then you do like for I in range, and then if a I equals 0, or equals, let it be equals 0, then you just eliminate, delete node age. But we can delete node as well, so there is no problem. We can delete this age, and then we will have another graph. So we have one graph, and we can get this graph 1 from initial graph using copy. Then we make elimination, and we can return this new graph. This is an idea of creating this informational structure generator, but it's very simple idea here. Okay, and then when we have utilities for every such graph or every such list of parameters, of course we can find here equilibrium as we did before. But what is new about this partition here? Okay, in this case, player 1, player 1, he knows that the game might be this one, but it might be that the game is not this one, but another one. With another vector of parameters, which this agent 1 is not able to distinguish. So maybe for him, graphs with these parameters are not available to distinguish. So he can't. So he doesn't know what game he plays. In this case, there may be two variants. Well, maybe it might be several ones. The first one, we create new game for him. Such that his utility function and utility function of his opponent, when we need, it's not quite here. So the utility for his opponent for checking if it's Nash equilibrium or not for his opponent, we should use initial U2 and U2 here. We should write a special condition for this. Maybe I will write it a bit later. And but for the first thing, he might want to have, I will denote it like U1 here and U1 here. And he will have, if he has probabilities here, probabilities of this worlds, for example, it might be that the probability of this one is half, and the probability of this one is half. So he will have U plus U2. It's like an average. But maybe he thinks that this world is more probable than another one. Then he might want to get here weights. It may be there. There's no problem. And he wants to optimize his expectation. So when we are talking about a probability theory, it's a good idea to talk about expectation. But when we want to check if it's well, and it's not mixed strategies here. Yeah, and this one is still equilibrium in pure strategies, pure Nash strategies. But what, how should we check if it's Nash equilibrium? For example, we find here one point that is optimal here for this player, for player one. What kind of conditions should we check for this for the second player? One, well, if it's a Nash equilibrium, then we might want to check if here is optimal here for U2 and for U2 and U2 here. Because in this situation, player one, he doesn't assume that player two have the same problems with uncertainties. So it might be that player two, he knows exactly what the world is. So he has no needs in probabilities. In this case, we cannot say that player two, he wants to do as he has to find this average, and no, he doesn't want. So in this case, we might want to check if it's Nash equilibrium here and here as well. But it depends. I will discuss details a bit later because it's important, but maybe not now. It's only task number, sorry. Task number probability here 8. This one is 8. Yes. Okay, but it's only one variant of thinking about this, and this one is not very easy because of this thinking. So how should we think about the second player? So maybe we will skip it, but we will definitely pay attention to the second variance. So this one is version variance 1, variance 2 here. This variant means that I don't care about well, U2 and here. I would like to check my own strategies. So we check for every player. Oh yeah, it's the same here as well. I will tell about it a bit later. So we check for every player here. Here we have minimum of u1, u2. So he thinks that the opponent and the nature, if nature plays here, so the variant will be the worst for him. So he will have, so it's like a max min here, max min idea. So he just replace these two matrices by only one, where he has just minimum of these elements, and then he tries to find the optimal situation for him. So this point is an equilibrium if in this matrix this element is optimal for this player. His strategy here is optimal. And we do this for every player. For this one, for another one, for example, if we have, oh, no, sorry, here, not here, and here. Yeah. And maybe the second player, he cannot distinguish other worlds, and it might be that for the second player we should check minimum of several other, maybe not 2, even 4 or something. But we will still want to check if it's optimal for him here, and we do it here as well. So if here agent 1, player 1, he has 2 worlds that he cannot distinguish, agent 2, he might have several worlds like these two and others. Not this one, but those that he can distinguish here. And then we check this condition for the second player, and so on. So it will be equilibrium if every player will be completely satisfied with this combination of strategies. This was an idea. And how many variants should we check? Okay, we should have here for this strategy Nash equilibrium. So we have only 2 players, but we have strategy. We have to choose strategies for player 1, for this instance of player 1, for this instance of player 1, this instance of player 2, and this instance for player 2. It looks like we have to check for strategies. So we will have situation like we have 4 agents. So indeed we have 2, but we should check this condition here for every instance of agent here. And if this condition satisfy, then we can say that it's Nash equilibrium. It might be interesting problem, but well, it's like an exercise, but not for you. You have many tasks to do, but to check the complexity of this algorithm. So how many, if we are given a graph or even game, and we have uncertainty, like a list here. So what is the complexity of finding all equilibriums there for this or for this situation? We can check it for Nash equilibrium. So there are several algorithms. I have introduced that one when we go from one element to another one. So we check all elements, and for all elements, we check all elements here and all elements here. So we have n square, and we have n here, and wait, sorry, to n here. We have to n for n square. So if I'm not if there is no mistake, it's like n square or something, to find all Nash equilibriums here. And we might want to check how many operations do we need to find the equilibriums here if we give specific edges. Okay, so it was just the description of the well, 8 and maybe 8 and 9 here, and 10. And then we might want to have a Pareto optimization, Pareto set, but I'm not sure that we should do exactly this one. Maybe we should skip. But these 3 are described here. As you see, it's much more complicated. At least it looks like much more complicated than previous tasks, like first one and second. But indeed, it's not so difficult to update software, because you may maybe already know what kind of code you should write to get this result. What we will have then, and then we will have very intuitive upgrades. But in this case, we should rewrite our code to allow checking these equilibriums and other things for several shops, for several agents, with several shops, and maybe possible coalitions. Is some kind of bonus here. I don't know if we will have time here. I would like to show some picture here. Sorry, it's here. Sorry, it's from another seminar, but the main idea, this is the informational structure for coalition. So this agent A, he doesn't know if B and D agents, B and D, are in coalition. So if these letters are together, it means that these agents with these names are in coalition here. So he doesn't know if B and D in coalition, C and D, B and C, or maybe there is no coalition at all. And if this is the case, then C, he doesn't know if there are coalition, and so on. There is an informational structure that is created indeed in the same way. It's also the partition, but slightly more complicated than we have discussed with you right now. Oh, yeah, it's here in 15. That's our plan for model 3, and maybe the beginning of model 4. And then, as I have told, I would like you to have some statistics here, like investigation. We will take a graph, and we check some properties of all these things. So we check if Nash equilibriums they coincide, and we take graph, and we check different parameters, and then we check if equilibrium will move or will be eliminated at all, and so on. So it's some kind of research, but indeed this research will be just checking parameters of all these models and comparing them. It will look very interesting. I think there will be several graphics and diagrams, I hope, but it's not so maybe difficult as writing the code here. Okay, and then maybe if we had time in the model 4 or somewhere, we will improve our initial game here, because here we have very simple game. well, it's like simple game of placing here shops and customers, but then we might want to create another function of utility, of calculating utility for agents. It might be any other one, and we will play with this thing. We will check what will change if we change here rules of our game, initial game, because in all variants here we have only one game, one type of game. So this one here is very important, how we get from graph to game, and we maybe want to change this transition to from graph to game, two different games, and we will have all different results here. But for this case, if we have written all this code, we don't need to rewrite it. So we need just rewrite this part of our code, and we will get all these results for free. Okay, this is our plan. We will do some of these tasks during our seminars and lectures, and I assume and I suggest you to work at home as well. So it's like a combination of homework plus our seminars, because we don't have enough time maybe during seminars to discuss all details. Maybe you want to use your time at home to test your code here, or maybe to present this code in a nice way. So it's like homework plus seminars here. But we will have time to write code at seminar, like we did before at previous lecture, and we will have time today. Okay, is there any question at this point? Please let me know. In this case, I will try to explain it. If no, then we can go to checking your result, your progress, your problems, maybe with this code. I think maybe we can start with Ilya. So Ilya, where are you here in this task list? So have you already written a code for, well, rationalization? Yes. Maximin equilibrium.
No, Maximin, not yet.
Okay. So you're here. Okay. What is the right? Ilya maybe here. I don't remember what is the right. Is it correct spelling, Ilya, here?
The first was right.
I have the same problem with my surname because my surname is this one, and there are rules that recommends using this one. So Y or I, and it's not very easy. I use the previous one with Y, but in some official documents they recommend to use I. So I just don't use I for not to have problems with this. Okay, so Emmanuel, how are you? So where are you now? So have you created a code for Nash equilibrium here?
No. Good morning.
Good morning. For Nash equilibrium, have you created a code? Have you written?
No, remember yesterday I told you I lost everything. I just started.
Okay. So you're here. Manuel. Well, I think that we have several more students but I don't see them now. I think that they're somewhere here. So now the first place for Ilya, the second for Emmanuel, and for all others, the third, fourth, and so on. Okay. So if you need any help or any feedback from me right now, or you can, or you know already what to do, Emmanuel, Ilya, do you know what to do right now?
Yes, I think.
Oh, Emmanuel, do you know?
Well, not absolutely. I think I need to read the questions. Try
Okay.
where I have challenges, I reach you.
Okay, I think that in this case, Ilya, you can write. You can work on Maximilian equilibrium, Pareto, and so on. So, as we have discussed here, and we can discuss details of Emmanuel progress. So, and we will be back and maybe. Okay, we have 10:50 break. So maybe 10:50 we will check. And then 11:10 we will discuss in more details. So 10:50 to check 45 to check before the break what we have written by these 20 minutes, and then we will have a break, and 11:10 we will continue and check if we have any problems, and we share our results and so on. Okay, Emmanuel, do you have a Python right now? Can you create a software?
Yeah, I have Python.
You have, yeah?
Yes, sir.
Okay, great. If you want, you can share your screen and show your code and how you write it. And I can, as I did at previous lecture, and I try to help you with this code. I will. So I can show my code. So I have created the code for uncertainties here. So when I have discussed this variance here of uncertainties, I have created a code which solves part of this problem. I can share it later, but it's task number 8, so it's not necessary to do it right now. I will share it later if it will be required. Okay, we can start from the very beginning. Do you have a script, Emmanuel, that I have sent before?
You shared the tabs yesterday with me.
Okay, do you have it? The script? But anyway, you can just share your screen and show your code, and we will try to go step by step to create these tasks. Okay? I think it will help you to create this software. Okay. I remember that at previous lecture we created a bit of code here there. We were looking for Nash equilibrium, I remember, at previous lecture. So we can continue from that point, or if you have any progress, we can continue from that point.
All right, let me see.
Okay. So I will close my window. So you can share if you want your window. It's up to you. If you maybe it's not ready, it's okay. But if you are ready, we can use this time to create this software. By the way, Emmanuel, do you have programming experience? So I'm a good software developer. So what is your favorite language of programming language? Is it Python or maybe another one? A Basic, Pascal, maybe?
I think I've only used Python. I told you.
Okay. because I think that maybe if you use MATLAB or any other language, maybe it's better to switch to this language. So it's okay, it's not a problem. We are not too much restricted to Python. If you want to use another language, it might be that we can use that language. Okay, Python, okay, it's a good choice. It's very popular language right now. So machine learning and other things, a lot of libraries. So it's not bad.
Maybe
Okay, yeah. How can I help you? Okay, yeah, I see your screen. Oh, great.
is this the tax you're talking about?
Yeah, it is.
I just opened it.
Okay.
Maybe you can explain so I understand.
Okay.
And,
Okay. I can start from the very beginning. Look at this code. Here we have the first step. We need several libraries. Maybe not all of them are required for us right now, and some of them maybe will be used later. It's okay, but I just included them to be sure that we will have all libraries right now. So the first library, matplotlib, will help us to draw pictures like diagrams or graphs and so on, and even graphs maybe. Maybe they are ready for plotting graphs. Yeah, they can. Then we need Seaborn. Okay, maybe this skip one because I don't use this library right now. NumPy. We need this library to work with matrices. So Python needs a special library to work with matrices. And so it's not just table. So sometimes we need to multiply matrices and so on. In this case, NumPy is very useful. So even sometimes we might want to use eigenvalues or some very special properties of these matrices and graphs as well. In this case, NumPy will be very useful, and it is very useful for working with data. So when you import your data, then you want to convert it to several other types, and NumPy is a very good thing. NetworkX is important for us, especially here because we work with graphs, and networks is a very popular and famous library that is required to work with graphs. Of course, we can try to use it. Well, can use other algorithms, but networks is very easy one, and he has many algorithms to find communities, to find clustering, cliques, and many other things, distances, diameter of graph, and so on. And for example, it has a very important for us algorithm. I don't remember its name. He takes adjacency metrics and he returns the metrics of distances between points, and it's already implemented in this this library, so it's okay. And we can show our graphs in a nice way using the NetworkX library. Then we have collections. It's for lists and for cycles sometimes. And we use pandas. It's like NumPy, but he has special features. So I don't think I use here pandas. Pandas is as I remember, pandas is very useful to import data. When we have real data, transportation networks and so on, we will have a special format in files. And in this case, we might want to convert from one type to another one, and pandas will help us to do this, as I remember. I think I used it once or maybe several times when I imported files there. So it's the first one. So we import just all libraries that we need. This is maybe the simplest place of our code. The next it's input to 28. I just create a matrix. So I need graph to make a game. It's not task 1, it's task 2 here. And I have implemented task 1 at the end of this file. We will discuss it. So the task 2 is if we have graph, we need to create a game here. So here I use NumPy library, and I use random. It's like a sub library. It's a collection of methods and a collection of algorithm. It's a part of NumPy large library that is connected to random, because I decided to use some randomization here. I decided to check algorithm and show you algorithm for different types of data. And one way is to create a constant graph just by typing all values, as we might want to do it 50 years ago. At the very beginning of computer science. But now we can use random. There is a special function that I don't use here, but you might want to use it. It's named seed. Or it's like it's seed in biology. It makes our random process, or this random generator, connected with a special number. And then if you want to get the same random numbers, the only way, because if we execute one more time, we get new random values. And this seed helps us to create random values, but the same random values that we had before. I don't use it right here, but sometimes it's very useful to be able to create random values and then use them several times. Okay, so it's just a matrix here. It's matrix, and the first parameter here is the minimal minimum value of elements in this minimum value of elements of this matrix. So all elements of this matrix from 2 to 20 to 19. So 2, 3, 4, 5, and so on, as you can see in this matrix. And then I here write size of this matrix 10 by 10. You can count. So they have 10 rows and 10 columns here. Is the first one. So we need some kind of matrix. It's data generator. Then I want to print it, to watch, to look at this matrix and to check if everything is okay. I do it by just printing print A, and I have this matrix that is shown here. Then I want to create a graph using my adjacency matrix. There is a simple way. So I use matrix from, I use a method from networks. So I use nx, that means that I use library nx, and a function graph that takes our matrix and returns object graph here, network, with his own properties. We can print it and we can draw. So network X helps us to draw our graph. Please show next lines of this code. Yeah, and this is the graph. It's not very interesting, but if we have a more interesting graph, it will be very funny to see it in their graphical representation. Okay, so we have graph, and then we need for our utility function not graph of adjacency. So this graph shows distances between two adjacent points like I and J, but we need but maybe it's not the shortest one. So for example, it might be that from point 1 to point 2, direct distance is 10, but from point 1 to point 2, distance is 1, and from point 2 to point 3, or to that point, is also 1. So there is no reason to go directly from one point to another one because it's too expensive, and it's more optimal to go through other nodes of this graph. And Floyd-Warshall algorithm, he shows us a matrix with such shortest ways, these distances between two points. So, sorry, here, yeah, NP mean is just for testing purpose, so I don't use it there. Then I get a shape of our matrix. In case if we have A of different shape, here it might be. So I decided to check if I have right size of this matrix, and this line means that a shape returns two values, a number of rows and number of columns, and we assign these numbers to n, am here. Okay, for our example, it's just n equals n, am equals m. And then I want to get path length here. So I use NetworkX library. I apply Floyd-Warshall algorithm to net. It's an important node where you use real data. You will have to think about clustering thing. Well, not clustering, but connectivity. It might be that your real data will have several connected components, but it will be impossible to get from one component to another one because borders are just closed. It's very similar to what we have now because of a pandemic of coronavirus. So we have several countries, and it's not so easy to get from one country to another one. So Floyd-Warshall algorithm is not so good for this situation. So you have to think and maybe to write a special code for this. But for task 2, since you have your graph, then you might want, well, of course, you should check the connectivity, but for our exercise, it's not necessary. So it's okay if you don't check it. For real data, you should think about it, but maybe it's not necessary because we can assume that we have one connected component. There is a special function that returns all connected components of a graph, so you can get your real data. Then you can cut off all other components and to focus on only one component, and then you can apply Floyd-Warshall or Warshall algorithm, and then check this idea. But you maybe don't want to use only one connected component. You can create utility function if there are several components, but it's a slightly more complicated task and it's not required here to handle this situation. But if you want to make your code more general, more powerful, you should check such component. Okay, when you have matrices of distances, then we might want to create a game. So before this, we had some kind of preparation for this, and now we can try to find a game. So here, sorry, we have four players. Well, four shops at place 1, at place 5, at place 2, at place 8. But for the exercise 2, we need, and for exercise, we don't need all 4. We need only 2 of them here, and we will use it here. So there are some subset here, but here is just an example. I have more updated code here to create it. I think I can, I will send you right now. And then here, what I do here. So I just get my matrix there, and I cut off all other columns except those who are specified here in this. So it's a list of columns here, and double dots here shows that we take all elements in this rows. So we have row, we have row, and we have several columns. First one, several, this one. We have new shape. It will be an equals n, as we had before. Am equals 4, because we have here only 4 shops. For exercise 2, we need only 2 shops. Okay, u and p zeros means that I created a vector of utility function of utilities, and then if I given a number of customers at every node here, for our exercise is just ones there, and p zeros and p ones creates vectors of the specific of distinct size for but zeros and ones vectors, and then I go step by in 2 cycles. So first of all, I want to find minimum. So the closest, the shortest, the distance between customer at every node to the closest shop. So it might be 0, 1, 3, or whatever. It's minimum. It's some kind of goals for our customers. So customers, they choose a shop. They will compare distance to this shop with a minimal distance to shops, the set of shops. And if the distance to the specific shop is not the closest one, then customers will ignore this shop. So they will go only to those shops that has distances that equal a minimal value of distances. And then in this case, I count non-zero elements. So count how many shops are at the same minimal distances from our customer, and number of customers bi here. So I have these customers. I split them into equal parts for every shop, and then I say that all owners of these shops get these customers. And here, sorry, wait a minute. Nope. Okay, here I have. I was worrying about power of my notebook, so it's okay now. So and then if our shop is very well, it's close to our customers, specific. So J is the number of shop, and I is the number of node, and then we assign well, we increase utility of this specific shop by the number of customers. And so we have 4 shops and we have utilities for every shop. So we have 3 customers or 3,000 customers which go to the first shop, 1,000 to the second one, 2,000 to the third one, and 4,000 to the next one. Okay, it was task 2. I will send you right now, wait a minute, my code for these Nash equilibriums and other things. Save as, wait a minute, not here. So I should download and like Python notebook. Oh, yes, I did. Okay. It's wrong. Is it okay? Wait a please wait a minute. I will send you in several minutes. Yes, okay, and okay, I see, I have it. I will send it is in Zoom, for example, or maybe in chat. Maybe in chat it will be better. In Telegram, so I will. Sorry, I will launch my Telegram here. And I will send you. Yes, here my code. I should take yes this one. Okay. Please check your Telegram chat. Our Telegram chat. There should be a new script that you can check. Yes, and Emmanuel, please try to download it and to execute, and check step by step if it's okay. If everything is clear at this script. Yes, I think maybe this one. Oh no, maybe not this one. Maybe another one.
Can I stop sharing this and upload the other one?
Yeah. The name of that is AQL 2021 1 and 2 in brackets.
Yeah, I've seen it.
Okay. Yes, here. Okay. So we have 2 minutes before the break. So you have break, and after the break, we will continue. I will check if Ilya did everything, and then we after the break we will continue with our Nash equilibrium with the discussion of script and other tasks. Okay, so at 11:10, but before that, Ilya, have you written any task, Maximin or Pareto things, Ilya?
Not yet. So
Okay.
let me check. Maximin, we for the first player we find the maximum value for the second player in each row.
No, not exactly. It's true if it is a zero or sum game. So if my opponent or if opponent of the first player is just a very enemy, so they play they have a resource and they want to split it, but sometimes it's not true and we want to have one general code for this. So maybe they can have some kind of a compromise or a consensus, and it's not a zero sum game. Then we might want to allow them some kind of cooperation, but in this case, Maximin, it looks like we consider every player separately in this case. So the first player, he doesn't think at all about utilities of other players at all. he doesn't think. He just assumes that all other opponents, all other players, that they want to do the worst for him. So it's like some kind of paranoia or something. So he thinks that every player in the world, the only aim for this player is to do the worst thing for this player. It might be not true, but for this equilibrium, it's some kind of reasoning. So we check. So for the first player, we use only the first matrix, only U1, and we find in each row the smallest element. It means that we imagine that the first player, if he choose the first row, and then the second opponent will do the worst for him. So we should check the minimum value there. And we do this for every row, for every strategy of the first player. And in this case, we just check which strategy has maximum minimum. So the name of this method is maximin. So the maximum of minimal variance. Okay. Is it
Okay,
clear?
thank you. I understood. And so the second player does the same, and we have these two strategies.
Yeah, that's right. And maybe, yeah, and then we combine them.
Okay, thank you.
Yeah, but think that maybe there are several equal values. It might be that we have several equal values. So there may be several strategies for first player that are equal. We should find all of them to make our algorithm very general. Okay, now we have a break. We will continue 11 past 10. 10 past 11. Okay. Okay, it's 11:10, and we can continue. By the way, there is a special like a competition for Ilya Sigalovich prize. Ilya, I think that maybe he's from Yandex somewhere, and you can, I think you can apply, but there are strict requirements like, about your marks, so and your success in your studying. It's for bachelor students, master students, for PhD students. Yeah, so you can check internet. There are some information I found in Russian, but I believe that there should be information in English. But it's very strong competition. But if you're brave enough and you have high marks and high progress on other courses, so you might want to apply there some kind of.
Are the grades considered for only 4 semester?
Okay. I will give you in the chat Ilya Sigalovich price. You can check details. Yeah, award in computer science. Here, sorry. Chat. I'm not sure if it's real because, well, the price, this award is real, but maybe it's not very easy to win it. So there is many competitors, but you can check details, and maybe if you feel yourself strong enough, you can try to compete with other students. Okay, now we can continue with our course. So, Emmanuel, you can now try to upload your the script that I have sent to your Python environment and check. So Ilya is working on min-max equilibrium and then maybe Pareto equilibrium. So I think that we might have a work here 11 maybe and a half. So 11:30 until 11:30 you have time to work on your code. If you need any advice or any guidance, or if maybe you need my help, so you just let me know. And if you have written your code, please show me. It will be great to discuss this code. But you have time, maybe 15 minutes before our next some kind of deadline, and we will discuss your progress maybe in 20 in a quarter an hour, so at 11:30. But if you need any help, please let me know. Maybe I can comment my code, my script, or some tasks. Maybe from theoretical point there are some uncertainties, so please let me know. Otherwise, at 11:30 we will check our progress. Okay, it's 11:30. So, what is your progress? Ilya, have you written a code for Max-Min and maybe Pareto?
Yes, I
Okay,
have the code.
okay. Wait a second. Emmanuel, what is your progress? Have you checked script? Is everything clear for you in this?
Yes, I checked the script. I realized that NP is not defined. That's what the error says.
Okay. So I
Yeah,
think
I tried replacing it with 10, like for instance, the N with 10,
mhm.
and it still didn't work. For
Oh,
some, like for one line, it worked. The others, it showed error.
okay. So we can check the code of Ilya. Ilya, you can share your code, and then we discuss with you, Emmanuel, details of the script. So this is the plan. So Ilya, could you please show the code if it is possible, and comment a bit. Oh, nice.
Okay, so here I have matrices U1 and U2, U1 and U2 from
Okay, from there.
previous
Okay.
seminars.
Okay.
So here I find minimums in each row,
Yeah, I see. Okay, nice.
and then get the indices of matrix max elements in this array, and the same for the second player. And then I just take the product and get one equilibrium.
Okay.
It's the same as Nash equilibrium.
Okay. Okay. It looks okay. Maybe we should test it later, but it looks not like it is okay. What about Pareto? Have you created?
Yes, I find
Oh,
it
cool.
by definition, so I
Okay.
try all E and G, and then I try to change
Mm-hmm.
the row and change the column and see that all values are not better. Although it finds the empty Pareto set. Don't know.
Empty
It's normal.
Pareto set is it's slightly strange. So there is no such element that players. So if we have empty Pareto set, it means that for every element we can find another element that is strictly better for. But isn't it like? Let's imagine there is a process. So we have an element, and then we check another one where utility is greater or equals of this. Oh, maybe because we have several equal strategies, then will just switch between them. But if not, so it looks like we can get element with larger utilities. Then we can get an element with a larger utility than the previous one, and so on. I'm not sure. Well, but utility will increase, and since utility has a maximum here, as we just can check maximum of all elements, a maximum of utility for all elements, and it will be upper bound. So it looks like we should go to the element with such utility that cannot be increased. In this case, this element will be Pareto, at least one element of the Pareto set. So maybe something was wrong with the definition, but maybe not. Okay, have you understood this reasoning? Yes, that you won, so you get another element which is which has large utility, and then another one, and so on, and there is an end. So there should be no cycle if this um, situation is if utility strictly increases. Of course, if we have equal, then we might have such cycle. Otherwise, there should be no such cycle. Hmm. Mm, okay. Okay. Um. Okay. We'll think. If it's okay with Pareto, maybe we should check it later. But you, you might want to check it right now. But if it's not very clear, you can try to um, start a discussion with this informational structure and this big topic, big domain with its uncertainties and so on, maybe. But first of all, please check Pareto set. Maximin, maybe Maximin is okay, but Pareto set, maybe you should check a very simple example. And if it's true for several simple examples, then maybe it's okay. But I think we should check for simple examples and then go to informational sets. Okay, thank you. So if you need any help, let me know, but I think the progress is great. So Emmanuel, now we can discuss errors and codes. Can you please show this script and comment what is your understanding of this script? So what was wrong and so on. So there is no error. So where do you have a problem here in this script? You have mentioned that you have an error there. At what line?
Basically,
Mhm.
looking at the script,
Okay.
you'll see that this random.roundit is 2 to 10.
Okay.
And in the previous script, I realized that n was 10. So I replaced the n here with 10. I changed it and it worked. But the problem is for the other n's, like for instance, here, and
Okay.
here.
Yeah.
Yeah. I tried to replace them with n. It did not work. And then even when I left it that way and ran it, I realized it showed NP is not defined. And that's the major problem here. So I wonder why NP is not defined.
Okay, I think we can check, we can fix it. So first of all, check here where we have input 52, we have n equals 5. You see here, n equals 5. And at the same time, we have matrix 10 by 10. So we should have a matrix the same size of n. So n is the number. So you should have here at nn where we have 10, 10. Or it's better check not n equals 5, but n equals 10. And I think, yeah, here. And try to compile everything. So execute not only one input, but execute all inputs. So it's like
so all the inputs, wherever there is n, I replace it with 10, right?
Yeah, I think it should be okay. No, you can hold n here, but try to execute everything. Not by no. Use cell execute all.
All right. So
It's very important that you should execute. Oh, not even okay about let the demo. Oh, it looks like it works.
there is
Okay, some warning. Yeah, but
We still have one in here.
yeah, warning is okay here.
It's okay, right?
Yeah, it's no problem here.
Okay, and why are we still having error here?
Try cell, but not execute run above, but run all. Cell run all. Yeah, here and run all. Here. It looks like everything is okay.
Let me watch. I think so.
Okay, that's nice.
Everything
So,
is okay.
yeah, it's a problem of script because in a good written code, there should be no such situation when we have numbers like 10 and variables like constant 10, and they, well, in the good written code, we should have not 10 but n in all places. It's just some kind of bug.
Okay.
But I'm glad that you have found it. Okay, now we have slightly fixed it. We can fix it completely if we go to upstairs, and here where we have 10, 10, 10, the size of matrix. Yeah, please replace it by nn, not 10, 10 by nn. Yeah, here, and try to run all again. Okay, it looks like we have a better written script. Yeah, if you find anywhere again 10, like a parameter, you should just replace it by n. I think it will work here. So your task is to understand.
So we still leave it as n equals to 10, or we change it to n equals to 5.
Yeah, you can try equals to 5. Okay, and execute all. Run all, yeah. Okay, we can check. Where is the problem? Not here. Okay. Okay.
5 is out of bounds.
Yeah,
Perhaps
I see. Can you go slide? No. Yeah. As you can see here, we haven't cycled 10. You can find 10 in our cycle 4, not here. Below. No. It's okay. Hold here. Below, you will have not here. Below. Not here. Not here. Not here. Not here. Yeah, here. I in range. You see, I in range from 0 to 10, but it should be n here. Yeah, here, and at the same places below. Yeah, the same at n here. Again. Okay. Here is okay. Okay. Okay, it might be okay right now. Please check. Okay, now it's okay. Yeah, the problem was that I used 10 somewhere, but when I decided to use n, I didn't replace 10 by n at every place. Okay, but so you have, well, you can try to develop your own code, but you can first, if you want not to, before you write your own code, check if you understand this code, because I think that it's maybe not optimal code, it may be not so elegant, but as it could be, but it's straightforward, direct way to solve our problems. So is everything clear in this code?
yeah, I think I now understand a bit.
Okay.
I can use this one to see if I can do my own code.
I think that there is the task for you right now that you maybe it's a good idea to spend time and find best data for task number 3. So
Okay.
yeah, there is a link. I will send it maybe again. A link to databases, site with databases of transportation networks, and I think you should try to download, to choose which one you want to use, download, and try to import this database as data set, as a graph. Okay, so I will give you a link. Yeah, here. Send you in chat. It's a complex networks link. And if you follow this link, you will go to datasets, and you should choose options, transportation, and others like roads, and then choose which dataset is more suitable for your tasks, for your problems, or maybe you just more like you like this dataset the most. Okay, have you found a link to dataset?
Yeah.
Okay.
The links.
Okay. Okay. It is important to check the format of this data set because they have data in different formats, and at the same time you should pay attention to size of this data set. If it is too small, like maybe 3 vertices or 10, maybe it's not so interesting. But if it has more than 100 or more than 1,000 or more than 1 million, maybe it's a good idea to avoid using this data set because it's too large. So you should find interesting small data set for these exercises.
Okay.
You can close, sharing your screen, stop sharing your screen, and just try to focus, on this database, and choose whatever you want. So there are, we have found with the other Rome roads, Italy, United States roads, and so on. So you can choose whatever you want, because we talk about logistics, so maybe there is an application that is very good, suitable for your real time work. So maybe it's some kind of oil transportation, I don't know, or something other. So I think that we can put our small deadline at 12. So it's or maybe 12:10. Yeah, at 12:10 we will discuss our progress. So if you need any help or you have finished your work, let me know in chat. I'm here. So if you know what to do and you have just to spend time to do this, then at 12:10 we will be back and discuss your progress. This is the idea. So Emmanuel, the idea is to find a good data set, download, and try to import it as a network. So it's not very easy task. Some students they use maybe several hours to do this because they have different formats, not very good ones, because they have to use different libraries of Python and so on. So you have to be ready for big problems there. But it might be the case that the data set will be very simple and very comfortable for importing. It might be so just one line and you have imported this data set. It depends. So it's some kind of luck there.
So for instance, I go for metadata.
Yeah. You should check which one you like more. I can show you right now the domain area just to be sure that everything is clear. So now you see my screen. This is this site, index of complex networks, and I use subdomain here and network domain, network domain, transportation here, and subdomain. What kind of subdomain? Roads, for example. I need roads here. We have many travel. Okay, no, just roads. We like to concentrate on roads. And then what I have, databases here. So it's United States, Barcelona, Chicago, it's Paris, London, India, Philadelphia, Birmingham, from United States, Rome. Ilya, he has chosen Rome, so maybe it's a good idea not to choose Rome to keep a diversity here. So Berlin, Euro Road, Germany, UK, and train networks, UK transportation networks, subways somewhere, like Chicago maybe now is not very popular. Okay, we can check whatever we want. For example, London or Paris. I like Paris, for example. And I see that we have about 42,000 of nodes here and about 51,000 of ages. It's slightly too large to consider. Well, there are several variants how we can simplify this. I have described it to Ilya before, so we just restrict our agents to choose spots for shops, not in every node, but we say, okay, you can place your shop near Eiffel Tower or Louvre, and there are no other places. So the game will be much shorter. But the main idea is maybe slightly too large here. But you can check Birmingham. So in Birmingham we have 14,000, maybe also not so small. What about Germany highway? Oh, okay. Autobahn in Germany, if like Germany, you have 1,000 nodes. It's slightly less than in Paris. So you might want to use, for example, Germany highway system or any other. So you will have now time to choose to download. So you see here is a link, and try to use NetworkX help to import your data into their graph. Okay, is it clear what you should do, Emmanuel? Is it okay? Okay, nice. So at 12:10 we will discuss our current. Okay, now it's 12:10. We can discuss our current status. I will start with Emmanuel. Emmanuel, have you chosen a data set?
Yes, I choose
Okay.
economic, trade, and then the World Soccer Data Paris 1998. But the problem is I can't see where to download it. I just saw complete data set.
Okay. Do you know how to get this data set into their graph? Or you don't have data set at all there?
Like I said, I saw the data set, but I clicked on the download. It is not downloading.
Yeah, it might.
Let me just share the screen so you can see.
Okay. Yeah.
See here, the download, it can download. I open this one.
Yeah, okay.
This is the complete set.
Okay, nice. Okay, it looks like okay. Here. Okay. Do you know how to import this data?
That's the challenge. How do I go about that one with this one that doesn't download?
But you see, this data is more about social graph. So maybe it will be a good idea to consider not connection between teams, but maybe networks. I mean, a transportation network.
All right. So I go back for transportation, right?
Yeah, I like this data, and I have another course where we analyze social data, friendships, and so on. But for this course, I think that maybe it's a good idea to use transportation. It will help us to focus on transportation. Though the same, we will have the same code, so the same algorithm. We even might have an interpretation for this. It's okay, but I think that maybe transportation is slightly better here.
Okay.
Because the logistics. When we use utility function, we should find customers who tries to find shortest distance. We can't interpret it in terms of social network. I mean, teams, and I get information, and I go to get some help from those who is more close to me. So to get information for their closest friends, and so on. It's okay, but let's start with transportation. Maybe it will be better.
I'm already there. I'm looking for.
Okay, nice.
One with this.
Okay. Ilya, have you developed this code? Have you written for Pareto and for with maybe informational structure? What?
I found what was wrong with Pareto code.
Okay, nice.
So I think that in this task, we will always have all pairs of strategies, as Pareto said, because there are two players and they divide all customers between them. So when we are making one player better, we make another player worse, and so every point is in Pareto side.
Yeah, I think it's some kind of theorem here. Yeah, I agree that this reasoning, and I think that it's true for every zero-sum game and for two players. We may, well, I'm not sure, but maybe we can prove the same theorem or lemma or statement if we have several players. So in this case, maybe, and if maybe one player has two shops, but yeah, it's zero-sum game. Yeah, that's right. So the Pareto set is not very interesting task, though but we have this algorithm, and when later we will change our utility function for non-zero sum game. In this case, maybe we will get more interesting Pareto optimal solution. Yeah, great. So you have found mathematics here. That's nice. Okay, what about informational sets, informational structures? Have you tried?
I don't think that I will
Okay.
have time to do this today. Okay. Maybe I will do this at home.
Okay. I think that you maybe want to start with this situation. I will give you the basic idea how to write. Well, right here. For example, if you have graph, if you have graph there, so as you remember, I use like this one. So graph, net is an X graph, but you can use another way of getting graph. And then maybe it's a good idea to get a function like mg, or you can find other name that gets graph and list here, like I told, and returns graph that is like I have written here. Okay, so just elimination several ages, and if you do this, you can even check the difference in Nash equilibriums. So you have graph, you have this list, and you might want to have a list of Nash equilibriums. So for one list, A, you will have Nash equilibriums. So you have special program for this. And you, for another list, you will have another list of Nash equilibriums, and so on. And this is a good start to write this code, and then you can get partitions and other things. In Haskell, if you're using Haskell, I think that maybe have in Python, so we can get like we have well, okay, yeah, later. So I will discuss later, but I believe that it should be a very elegant way to get this partition. This one is in Haskell, so maybe there should be even a special function that get list and then makes such clusters. But I don't remember its name. I will check it until the next lecture. But maybe you already know this function. I believe that this function should exist, and you can use it for this partition if you need. But you can start with this one. Yeah, we have only we finish at 12 and 30. So we have maybe 10 minutes. We can discuss plans, tasks, maybe some theory. If nothing, we can continue, and we will just do maybe something to test something. I don't know, to pay to check. Maybe one more database. Well, think about this. Our plan, like like we have here, and let me know if you have any question here. Yeah, I understand that it's very difficult to write this code today because we have only 10 minutes. But I think it will be great if Emmanuel choose the data set and download it to the graph into Python. It will be great. If it
I think I saw a data set for.
Okay. Try to download it and into Python too. And Ilya, okay, Pareto. You have created Pareto, Maximin, Ratson rationalization. Okay, maybe you just should try to touch this new problem with information structure and so on. Just maybe think about it, and we will discuss in 10 minutes. Well, yeah, at 12:30, we will have final check for today. We will just check if we all know what we should do during next week that we have planned for doing it in 8 minutes. Before that, I don't think that I should give more information since there.
Can I share this data set?
Yeah.
please?
Okay. I think we can spend time to this. Okay. Alaska. Okay, I see. Okay, nice.
Are you seeing?
Yeah. What kind of transportation? Oh, okay. We consider the social relationships. It's not what. It's more about social networks.
It's social, right? So I change it again.
It looks like social thing. Yeah.
All right. Okay, what I will do, I will look for a data set that has to do with non-social networking. And then I will send it on your chat. We'll discuss it at your time. Then I'll work on it.
Yeah. Okay.
Meanwhile, the previous work, I will try to develop my own code, and I'll share it with you too.
Okay. Yeah, nice. So at this site, there is a special check box where you can restrict all networks to transportation networks. It will help you to choose because there are many other networks, and transportation networks is only a small part of all databases, that all data sets that there are.
What I did was I clicked on transportation, and then I clicked on road. That was where I got the previous work.
Okay.
But if it is social, then I think I need to click on what do I actually need to click on, because the previous one was on load under the source.
Let's check. Could you please show your screen? We can try to find it
Okay.
directly.
All right. Hold on.
Yeah, that's right. Correct. That's me. It's my link.
And then network domain. Yeah, transportation. Subdomain.
I see only a Telegram. I cannot see your Explorer.
All right.
Maybe you should change application. Yeah. Okay. Yeah, this one. Okay, yeah.
Transportation.
Right. Subdomain roads. Okay.
Roads.
Right. Enter. And you can look below there. Yeah, these ones, and you can choose from these data sets.
Yeah, that was where I chose the other one.
Yeah. Because there is no social networks here. I mean, there is a transportation, highways and roads, trail. Whatever you, I don't know, Sydney, maybe Berlin, or maybe US air traffic, or Chicago, or European network, whatever you want. Berlin, okay, Germany. We have several paths here, so you can use. I don't know. Maybe it's a part of Berlin, so like districts, maybe. So you can use Friedrichshain. I can speak German right now, so I'm only trying to learn German. So I'm not sure that I can
all right
pronounce it right. Yeah, you can check. There is a source here. You can get information from there. No, if you like Berlin, you can take it. It's okay. Berlin.
Okay.
So try.
So do I take the second set?
Okay. Yeah. Okay. Nice. Yeah. Try link. Yeah.
So I
Okay.
open. Are you saying?
They have a special format. Okay, I'm not sure that I have clear understanding of what kind of format they use.
All right, then I think we do someone. Let's.
Yeah, maybe we should use the data set with very straight and direct way for importing, because we are not restricted to specific country or specific city. We can use that data set that has very good Barcelona.
So can we use US airport network? This one.
Okay, I think it's okay. Yeah, why not? Okay, 50. Okay, nice. Age list. I think it's okay.
This
Try
one
it.
is okay.
Okay, it's rather small. Okay, top.
So can I click on the link?
Yeah, please. Okay. Okay, waited. Okay, waited. Static one mode network. Which one? Usenet format. Oh yeah, I know this. Vespignani. This is very famous, one of the best scientists in the social network analysis. Okay, but so you can try to download this. I believe. How to load? Okay. Oh, but I think it's not very easy. Maybe.
Yeah.
So you must download inside the L file library. Okay. Maybe this is not very good here as well.
All right, then let me close it. It's kind of.
Well, I believe that there are different ways to import this. It's no problem.
What about Harvard Economic? About this one is social. Sorry.
Yeah, it's economic. Yeah.
It's social.
Yeah, it's more social. I like social data. Well, I like social networks, but yeah, logistics. Try
All right, so I can look for one.
Yes. It will like homework to find this network that is transportation and at the same time have very easy format to import. Or maybe you can find very great database with very difficult format, but you can invent or find the way how to import this. It's okay. If it will be easy for you, okay. TPM. I'm not sure that TNTP is a very easy format to import here.
Okay.
Okay. I think now we have to stop here. We have only 2 minutes before the finish of our today's seminar and lecture. I will check that everything is the plan for Ilya is informational network or informational structure. Informational structure when we have a graph and some uncertainties, and to try to write a code to handle this. So for Emmanuel, it will be a task to find database and import it into Python. So both tasks are very difficult because information structure, because it's something very new, so it's not about game theory directly, so it's some kind of informational structure about like cognition and uncertainties. It's usually not very easy, even from philosophical point of view. And for Emmanuel, it's very difficult because it's format, different networks and different formats of this data. Okay, so I think we can finish. If you have any question, let me know. If not, I'm available using Telegram or email, for example. And I see you next week at the same time. Thank you for coming.
Thank you.